Dear students, today in this class I would like to talk about the mechanism of evolution. What is the basic mechanism that is normally happening during the process of origin of species? Now, and which I have to take what is microevolution. Evolution on a small scale. The meaning for that one, the evolution due to change in the gene structure, due to change or due to modification in the gene structure. Okay, so we have studied so far even the case of natural selection. Number of individuals only, number of heads only he calculated. But here in this one we are talking about the change in allelic frequencies of the genes. So based on this one, what do you mean by microevolution? Change in allele frequencies within a population. So just we have evolution on a small scale that refers to what we have change in the allelic frequencies or the gene frequencies. Change in allelic frequencies within a population is called microevolution. Now, there are four major fundamental evolutionary forces are responsible for change in allelic frequencies. What are the four major evolutionary forces? Number one, natural selection. Here we are talking about natural selection based on what is called genetics, not based on the principles used by Darwin. The second one, gene flow or migration. The third important factor or the force, genetic drifting. And the fourth one, the mutation, the main cause of variations. So we have natural selection, mutation and gene flow, genetic drift all operating on a population. So we have the population and this is being acted upon by these four factors, resulting in change in gene frequencies. Ultimately we have the evolution, nothing but the formation of species. Okay, this is the one. So we have to talk about natural selection, gene flow, migration or genetic drift or mutation, one after another. According to modern synthetic theory, now natural selection is a population-oriented genetic phenomenon. Darwin calculated the number of individuals, not the number of genes in a population. But here, as per the modern synthetic theory, now it is based on population genetics. What is population genetics? The study of frequency of genes or the study of frequency of genotypes. That is called population genetics. So study of frequency of genes or the study of that is what is called frequency of genotypes is called what is known as population genetics. So that's why I say now as per the modern synthetic theory, natural selection is a population oriented genetic phenomenon. Now it occurs when one allele or a group of alleles, a combination of alleles of differences, makes an organism to be fit, to be actually more or less fit to survive. Makes an organism more or less to fit to survive and reproduce in a given environment. So if the allele is favorable, it gives fitness to the organism, then the organism can survive, fit to the environment, the given environment and reproduce. Suppose if that allele reduces its fitness, that is reduces fitness, ultimately what will happen? Its frequency drop from one generation to the another generation. So its frequency tend to drop from one generation to another generation. When the allele is having actually fitness to make the organism to survive, then its frequency is there normally. When it reduces its fitness, ultimately the gene frequency tend to drop from one generation to another. If you are just actually finding the pathway of gene, if you are just calculating the pathway of gene, what is the mechanism of pathway of gene? It is nothing but how a gene's allele change in frequency in a population. over generations. And it may be due to several evolutionary mechanisms or factors. They are operating together at once. For example, I mentioned 4 factors, either mutation or genetic drift or gene flow. Okay, mutation, genetic drift, gene flow, etc. For one gene, its allele, that is normally being modified, produced into a new allele by the action of both genetic drift and gene flow for one gene. For another gene, the mutation causes a change that results in the formation of new alleles, which is favored by the natural selection. So, many factors are operating together at once, or only one factor is operating at once and causes what is called change in allelic frequency. In one case, 2 factors. In another case, only one factor causes a change in allelic frequency. So, a number of mechanisms are operating together at once at the same time. This is what we have regarding the natural selection related to genetical oriented phenomena. Now, there are 3 different types of selection. One, stabilizing selection or centripetal selection. Another one, directional selection. The third one, disruptive selection, otherwise called centrifugal selection. Of these 3 selections, the most important one is the disruptive selection. This is the most important one. That is the one which produces evolutionary change. That is the one which brings about the formation of new species. So of all these 3, evolutionary change is brought about only by the disruptive selection. It is the one that leads to speciation, formation of new species. It causes an evolutionary change. But it is the rarest form of selection. It occurs rarely. Now coming back to the stabilization selection. So the most important selection, disruptive selection, the one which causes evolutionary change, the rarest form of selection, as per the name also. Now stabilizing selection. This type of selection occurs only in the stable environment. If there is no change in the environment, at times only we have stabilizing selection. Now here I am just drawing a graph, just taking phenotypic distribution in x-axis, and phenotypic frequency. There is a number of individuals in y-axis. Now I am taking, for example, the length of neck in giraffe. There are 3 different neck lengths. One, a short. I represented here one extreme. Another one long, another extreme. And we have the medium sized neck. This is not given in the book. I am telling simply short necked giraffe, long necked giraffe, and what we have a medium necked giraffe. So this is a normal one, normal curve showing the normal distribution. What do you mean by stabilizing selection? I mentioned already, it is normally occurring in a stable population. This type of selection selects or favors the individuals in the mean value. For example, medium sized neck. Okay, and eliminates those individuals that is short and long necks at the extremes, at both the extremes. As a result, what is happening, more and more number of individuals are there in the mean value, and other extremes are simply eliminated. That's why the peak becomes higher and higher. So individuals with mean character value are favored. In the case of this, what is called stabilizing selection. Individuals with mean character value are favored. Now going to the next one. So what about the example given in the book? In the book it is given the sparrows. And those sparrows which are adapted to survive, that is to the storm, they can just survive and reproduce. And those sparrows fail to survive actually to the storm. They are actually clouded together normally at the 2 extremes of the variations through natural selection. So those which can withstand the storm are favored, they are being clouded in the mean value. That is actually medium sized individuals, or we can say average phenotype. And other 2 extremes, one extreme, another extreme. Here I removed these two. So the two extremes, the individuals and the phenotypic distribution of the two extremes are eliminated. And this type of selection does not produce any evolution, does not cause any evolutionary change, does not produce any species, but maintains a stability within the population over generations. That is about the stabilizing selection. Now the next one, directional selection. This type of selection operates when there is a gradual change in the environmental conditions. Now this type of selection occurs only when there is a gradual change in the environment. Now here what is happening, you can see that one. Now this type of selection tends to eliminate the phenotypically extreme individuals and shifting the mean value towards one direction. So either towards the long necked giraffe or towards the short necked giraffe. That means individuals other than the mean value are favored. If you are taking the length of neck, either the short neck or the long neck being favored. Individuals other than mean value are favored. Okay, this is actually removing one type of individuals and shifting the mean value towards another direction, hence called directional selection. Now the stabilizing selection is called centripetal selection. It is operating from the periphery towards the center, eliminating the extremities and favoring the individuals at the center, hence called centripetal selection. Now here the directional selection, if you are taking for example the sparrows with reference to the size, the male and female sparrows. The male and female sparrows are larger actually, generally speaking, they are similar in external morphology. There is no difference. But with reference to the body weight, the males are having more weight than the females. So what is happening? The females show directional selection from the median weight towards what we call that is large weight. So they are showing what is called directional selection towards the weight of the body. This is the example given in the book. So males have large weight or huge enough size, and the females having medium size, having less weight than the male. That is which they show directional selection in one direction from the median size towards the large sized individuals. That's about the directional selection. Now the third type of selection, disruptive selection. This type of selection is the rarest form of selection, what I mentioned earlier, and also it produces evolutionary change. When it occurs? It occurs when the homogeneous environment becomes heterogeneous environment. Same type of people, different type of people. So, when the homogeneous environment becomes a heterogeneous environment, we have the disruptive selection. Now it occurs from the center towards the periphery. That's why it's called centrifugal selection. It divides the entire population into two subpopulations or species. Now this is a subpopulation 1 and this is subpopulation 2. These are actually the two populations which are produced by the splitting of the entire population into two subpopulations, or actually you see that one species. So I mentioned already it produces evolutionary change. It produces one or more species within the population. So when a disruptive selection produces more than one population, then the phenomenon is called polymorphism. When the disruptive selection produces more than one phenotype, then the phenomenon is called polymorphism. Now here what is happening? Here the splitting occurs from the centers towards the periphery, hence called centrifugal selection. So what's the meaning for that one? Here the peripheral characters, the phenotypes at both the extremes are selected, whereas the medium or the average phenotype individuals are eliminated. That's the meaning for that one. Individuals at both the extremes are selected and the average phenotype, that is normally eliminated. So this type of selection normally selects the peripheral character value at both the extremes of the phenotypic distribution. Now if you're taking the big size, the best example of Darwin's finches, the big size is related to the same size of Galapagos Islands. That is the one what is seen here. So rarest form of selection produces evolutionary change, produces polymorphism. It results in speciation, 2 or more species as subpopulations are formed, and it eliminates only the average phenotype and favors the individual at both extremes. So this is with reference to what we have destructive selection. And here another diagram represented regarding the natural selection with reference to dark environment. The dark environment I am taking the beetles. So here the beetles have 3 different types of genotypes and 5 of them are homozygous recessive. So these individuals are homozygous recessive, and 4 of them I have taken what is called heterozygous dominant, and 1 individual, this is what is called homozygous dominant. So in the dark environment what would happen? The light grey bodied beetles are actually eliminated because they are being spotted and eaten more often than the what is called the darker ones, because the background is very dark. So the grey colored ones or the light colored ones were normally eaten by the birds. So they are simply eliminated from the population. The rest we have the 5, that is heterozygous dominant and homozygous dominant. They are actually, if X is eaten, here I put what is called X on these homozygous recessive individuals. If X is eaten by birds, then only survivors reproduce. The only survivors are nothing but heterozygous dominant 4 in number and homozygous dominant just normally 1 in number. Now here this is also heterozygous dominant. This one is also heterozygous dominant. So they are being transferred to the next generation. They produce more individuals with more number of heterozygotes and also more number of homozygous dominant, and the least number of, you see that at least 2 I mentioned here, homozygous dominant, because the number has been reduced. So the allele with the frequencies, the allele with the survival value, the allele just having the fitness, then its frequency increases. So here the frequency of dominant E and also the heterozygous genotype, homozygous genotype increase, whereas homozygous recessive individuals just drop to a little bit. This is because of survival. This is because of the fitness of the allele. So this is with reference to what we call the natural selection also. Okay, that's about the first factor responsible for what is called change in allelic frequency. We are talking about in terms of what is called population related genetic phenomena. Not counting the number of individuals, we are counting the number of genes. That is called gene frequency or genotype frequency. The second evolutionary force responsible for bringing about allelic frequency change is the gene flow migration. What is gene flow migration? This is nothing but the migration of genes. The genes are not moving. They can move either through what is called the gametes because of interbreeding between the members of 2 populations. I am taking population A, population B. So genes are not migrating, but the carriers, for example the gametes, by means of interbreeding, by means of reproduction between 2 populations, now the genes are transferred. Or because of the movement of the individuals as a whole, from one population to another population. If enters into one population, that is called immigration, moving in. If an individual moves away from the population, then it is called what is known as emigration. So, the migration of genes, either through gametes or through movement of individuals, either by what is called immigration or by means of emigration, is called what is known as gene flow migration. Now it brings about allelic frequency change. Now this gene flow normally just brings a new allele or brings about the existing allele. That means it may produce what is called new alleles, or it brings about the existing allele but in different proportions. See here, from population B, a homozygous dominant individual is moving towards another population where you have only homozygous recessive individuals. As a result, we have one homozygous dominant individual is being increased. So the dominant gene frequency is added. So plus 1 here, there is a loss. So minus 1, we have in this case minus 1, here plus 1. So in both the cases you can find change in allelic frequencies but exist in different proportions. Now this gene flow is one of the important agent, most important agent of what is called evolution. Most important agent of evolution. That's about what we have the gene flow. Now another one, the genetic drift. It is an evolutionary mechanism which causes allelic frequency change in a population over times by mere chance fluctuations. By mere chance fluctuation. So I can repeat another way. A change in allelic frequency in a small sexually reproducing population by chance is called genetic drift. Now, though genetic drift is possible for all the population sizes, but its effect is more and more strong in small sized populations. Even the neat question also, genetic drift is possible either for island population or small population. Island population is an example for small population. If both the options are given, you have to choose only the small population. So a change in allelic frequency in a population, a small population, over time, due to chance event. What do you mean by chance event? The natural calamities. Say an example of flood, storm, tsunami, earthquakes, etc. And also even meeting the accident while we are riding a bicycle, while we are riding a two-wheeler. That is also an example for chance. So because of the chance event, the allelic frequency is being reduced. So it is concerned with the decrease in allelic frequency. So normally genetic drift tends to reduce the amount of genetic variations. So genetic variations means if you are taking the genotype, we have 3 different genotypes. Homozygous dominant, heterozygous dominant and homozygous recessive. This is what's called genetic variation. If you are taking any character, if you have 3 different varieties based on the genotype, then it is called genetic variation. Now genetic drift tends to reduce the amount of genetic variations by eliminating the individuals with less adaptive value. While eliminating the individuals with less adaptive value, it also eliminates the beneficial genes also. Okay, that's about what's called the genetic drift. So it is possible for a small population. It is related to the change in allelic frequency. It is due to chance events. For example, if a group of ants are moving on a ground, when a person accidentally just crushes the ants by placing the foot on it, it is also a chance event, reduce the number of individuals. That is also a kind of genetic drift. Now here, the genetic drift normally tends to eliminate the genes. So it causes the loss of genes, including the beneficial genes from the population. When there is a loss of genes from the population, then it's called loss. And also, it also causes the fixation of genes, then it's called fixation. So either it removes the genes, then the phenomenon is called loss, including the dominant or what we call the beneficial genes. When a particular gene is fixed in a population, that is called fixation. Now further have to explain the simple formula for Hardy-Weinberg equilibrium. If you are taking the dominant gene and the recessive gene, both together constitute 100%. That means there is what we have an equation P plus Q is equal to 1. P plus Q is equal to 1. That means P refers to the dominant gene frequency and Q refers to the recessive gene frequency. So both together constitute 1. Okay, if you want to know the frequency of P, we have to subtract 1 minus Q. If you want to get the frequency of Q, you have to subtract P from the total number, either in fraction of 1 or in forms of 100 or percentage. Okay, so here P plus Q is equal to 1, that's regarding Hardy-Weinberg equilibrium, we will talk about next. Now, this genetic drift is away from Hardy-Weinberg equilibrium. Now, there is a loss I mentioned. Here P plus Q is equal to 1 according to Hardy-Weinberg equilibrium, but according to genetic drift, P or Q is equal to 1 or P or Q is equal to 0. What's the meaning for that one? So, dominant gene frequency plus recessive gene frequency together 1. Here, P or Q is equal to 1. Imagine that one chance event when two students or two persons are riding on a bike. They met an accident. Out of the two, one person with the recessive character lost. Now we have only in that population just only the person with the dominant character. So in that case, P or Q is equal to 1. Meeting an accident, one escaped, one died. Either it may be Q or that is P. In this bar. The second case, P or Q is equal to 0. Meeting an accident and both died. So there is no dominant recessive gene for that character in that population. So this is what we call the genetic drift. When there is a loss, actually one of the two genes being lost, then it is called the loss. This is called 0. When either P or Q are both lost, then it is called the loss, both the genes being lost. Then if one gene is being lost, another one is actually surviving, that process is called fixation. So P or Q is equal to 1 is called fixation, P or Q is equal to 0 is called a loss of both the genes in the population. Now, we can calculate the frequency also from that picture. I've taken nearly 10, that is betas. Now here 5 of them are, that is what we have 5, and 4 of them are heterozygous and only 1 that is a dominant. I mentioned about, we see the green. Now what is the frequency of A? I mentioned 0.3. How can you calculate? Now this one is equal to 1, that is 0.1, we can say 0.1. By counting just this one, this one, this one and this one, heterozygous, we have to take only 50% because both dominant and recessive genes are present. So 4 into 0.5, we are getting just, you see that one, 0.1, 0.2, totally the frequency 0.3. Here we are taking the total because both homozygous, and here we are taking only half of that heterozygous. So 4 into half, you see that one 0.2, so the frequency of A is equal to 0.3. The remaining frequency is related to 0.7. So this is 1, 2, 3, 4 and 5. Okay, just. And also here in this case, also, so we have 6. 3 plus 2, 5 and this 1. Here if you are calculating that 1, 2, 3, 4, 5 genes. The remaining you see that when we are 50 each, 50% each. So 0.5. So the frequency of A is equal to 0.7. Why are they giving the 0.3, 0.7 accordingly what? Here we have to take only 50%, either for capital A or for small a, 4 into 0.5, 2. The remaining we got just actually see that 1, 2, 3, 4, 5. So 5 plus 2, 7. The frequency is 0.7. You see that one, the total value 1 or 100%. So this is what's called the gene frequency. Now what is happening because of the chance event, either because of flood or any other events, all these individuals died. Only these three individuals escape with homozygous recessive. So they just pass on to the next generation and produce only the homozygous recessive individuals. Now the frequency of capital A is equal to 0, dominant gene. There is no dominant gene here in that population. So the frequency of this actually recessive gene is equal to 1. All are homozygous recessive. So this is the way the gene frequency occurs, either because of loss or because of fixation, etc. That's why given in the book what you have to understand this one. So in the previous illustrations I showed the frequency, how the frequency changes. This is because of various factors due to Charles event. That's why we have only the recessive individuals being formed in the next generation. Now the genetic drift has two major effects. One bottleneck effect, another one founder principle or effect. So what is bottleneck effect? It's nothing but the natural calamities. So because of natural calamities, the size of the original population reduced into small. So that what will happen? The frequency has gone down. When the small population regains its original size after some time, it has developed the genotype different from the parent population. That is called bottleneck effect. So change in allelic frequency or genotype frequency temporarily, this is because of the natural calamities. And that resulted in what is called reduction in population size. When the population regained its original size, it has genotype different from the parallel population. Now this is the parallel population, this is a new population, and we have that is a reduced population. So bottleneck effect can be represented easily if you are taking a beads in a bottle. When the bottle is tilted, few beads came out. Now collected here, this is comparable to the small population. When you are adding more and more beads to fill the bottle, you are regaining or restoring the original, just a number of beads in that bottle. In the same manner, what would happen? This is a parent population comparable to the beads. The number of individuals more. Because of the disaster, because of the natural calamities or bottleneck, the number of individuals got reduced. We have the population smaller in size. Because of reproduction, they regain or restore their original population size. If you are comparing this on the new population, the genotype of the members of new population entirely different from that is the original parallel population. This is called bottleneck effect, one of the type of genetic drift, or we can say one of the major effects of genetic drift. Another one, what is called the founder principle or effect. When a group of individuals become the founders of a new population through genetic drift, the phenomenon is called founder principle or founder effect. So when a large population split, suppose it's a large population, from that one, a small group of population or individuals split. So this is a splitted population. A splitted population. And they become the founders of a new population gradually through genetic drift. Then the phenomenon is called founder principle. So these individuals become the founders of new population. That's why I said, when a group of individuals become the founders of a new population, then the phenomenon is called founder principle or founder effect. Or when a large population actually splits, or we can say in this way, a small group of individuals of a population split and becomes the founder of a new population through genetic drift, gradually. Drifting means gradual movement, resulting in the formation of a new phenotype, having a new genotype different from the parallel population. So that is what is called the founder principle, the second type of genetic drift. So these are the two types of genetic drift. The last evolutionary force or the factor responsible for causing allelic change, frequency change in genes, is mutation. Now what is happening because of mutation? So although you see that when the mutation is responsible for causing variations normally, but the rate of mutation is, or the mutation rate is very low. You can have 1 in 10 billion genes only or 100 million genes only we have the mutation. The rate of mutation is not normally higher. It is very slow. So that we have, when the mutation, a new mutation produces, that is genes, that will not cause much change in the next generation. The rate of mutation is low. Even the mutation causes actually change in the genes, that does not bring about a major change in the next generation. This is because of the less mutation rate. But mutation is also one of the factors responsible for causing allelic change, the frequency of alleles. Suppose you are taking gene E, when it becomes mutated to A, small a, here suppose there are 100 genes, so -1, so here there are 100 genes plus 1, so the frequency increases. So A gets converted to small a recessive gene, so one more gene is added to the recessive condition. Here one gene is lost from the dominant one. So anyway, change in allelic frequency occurs, that is through mutation. But the rate of mutation is very low, so it doesn't cause much change, large change in the next generation. So with this I concluded the factors, the forces responsible for the evolution. We completed the mechanism of evolution. We have to go for Hardy-Weinberg principle in the next class. Thank you.